So this lesson is talking about vector components or component vectors. Um, our learning target is the same as before. I will interpret and apply vector representations to analyze the magnitude and direction of physical quantities, identifying patterns and connections across different contexts such as force, motion, and fields. Okay, so basically, vector components are vectors that are drawn diagonally, right? Can be broke down into an x vector and a y vector, okay? So if we know what this vector is, what the size is, and what the direction is, we can figure out what the x component is, like how much it is, and what we know that it's going in the x direction. And then the same with the y direction, what the y component is. Okay, so to calculate the magnitude of vector x or vector y, ensure that the angle given is the angle from the x-axis. So if they're talking, if the problem says degrees to the ground or degrees to the horizontal, then you're in good shape. If it says, a different angle like this one, then we need to figure out what we'll have to subtract it from 90 to get to the right angle. Okay. And then use the equations to calculate the component vectors. Okay. Here's an example. We have a car that has a displacement of 150 meters in the direction of 40 degrees to the horizontal. What are the plane's distances in the north or y direction and east x direction? Okay, so we're given that the vector itself is 150 meters and that the direction is 40 degrees. What we don't know is what is the displacement in the x direction and what is the displacement in the y direction. So what is the x vector? What is the y vector? Okay, we're going to use the two equations that you were given above. Again, make sure that you write this down. So we're going to use, for the displacement in the x direction, the magnitude of the actual vector times the cosine of the direction. So for the x direction, we have A is 50 meters per second. Cosine theta is 40. When you put that into your calculator, you will get 115 meters. So from here to here is 115 meters. Okay. Same for the y, except that we're using sine of theta instead of cosine. So in the y direction, we have 150 is the original vector. And then we're going to multiply that by the sine of 40 degrees. That's the direction. And then when you do that in your calculator, you get that it's 96.4 meters. Okay. So the solution is that the distance in the east direction, right? That's your x, is 115 meters. And your distance in the north direction or the y direction is 96.4 meters. Okay, so to sum it up, we can break vectors that are already at an angle down into their x and their y vectors. And we need to ensure that the direction, the angle is the angle between the x-axis and the hypotenuse.